So we're going to start today with the quadratic formula. And so we're going to start by first talking about where the quadratic formula came from. So we're going to talk about a quadratic equation in standard form, and we're just going to simply go through the process of completing the square. And so I'm going to start by getting rid of the a value so that the x squared is by itself. So if I divide everything by a, I will have x squared plus b over a times x plus c over a equals 0. But then I want to get this c over a out of the picture so I can make this a perfect square. So I'm going to have x squared plus b over a times x. I'm going to leave a space here. That's going to equal negative c over a, and I'm going to leave a space here. So I'm going to want to write this, the left side, as a perfect square binomial. So it's going to be x over half of b over a. Well, that's b over 2a. Take half of a fraction. You can either double or cut the numerator in half or double the denominator. And so that's going to be x minus b over 2a squared. But in order to make this b over 2a, I'd have to square it and put that here. Well, that's going to be b squared over 4a squared. And so I'm going to also add b squared over 4a squared on the right-hand side of my equation. And so I'm going to need to get a common denominator here. I'm going to multiply here. This is by 4 and the top by 4. I'm going to need it to make the a squared right here. So I'm going to multiply by a and make this a squared. But that also means I'm going to have to multiply the top by a. So that means this is going to be equal to negative 4, I could say CA, but I'm going to say AC, over 4A squared plus B squared over 4A squared. Well, that's the same thing as if I put the B squared first, B squared, and then minus 4AC over 4A squared. So let me get rid of just this here. Okay, so then I'm going to go back and I'm going to take the square root of both sides. And so I'm going to have x minus b over 2a on the right, or on the left, and that's going to equal plus or minus the square root of b squared minus 4ac over the square root of 4a squared, which is just 2a. Then if I add b over 2a to both sides, if I add b over 2a here, these will cancel, and if I add b over 2a here, then I will have x equals positive b, if I do this one first, positive b plus or minus the numerator over here, which is b squared minus 4ac, all over the common denominator, which is 2a. And so what we have then is an equation that involves the a, the b, and the c. And if we plug those values in for the a and the b and the c down here, then we'll be able to get our answers all the time. So let's take a look at this. And if you haven't written this down, this is the formula that you should have memorized, and hopefully you do already by now. Let's see how this works with an example like number 1. We have our a value, our b value, and our c value. So it's going to be negative b, which is negative 6, plus or minus the square root of b squared, which is 36, minus 4 times a, which is 5, times c, which is negative 2. And that's all over 2 times a, which is 10. So what I'm going to do is take the square root part. That's 36, and I have a negative and another negative. So it's going to be plus 4 times 5 times 2. Well, 4 times 5 is 20, and 20 times 2 is 40. And so this is the square root of 76. And so I want to simplify the square root of 76 if I can. And that would mean I'm going to have, let's say, 4 times, I think that would be 19, goes into 76. And so I can write this as negative 6 plus or minus the square root of 4 is 2 times the square root of 19 all over 10. And I could simplify this further because all 3 of these terms, there's 1, 2, 3 terms, they're all even. I can divide everything by 2, and that would be negative 3 plus or minus the square root of 19, or 1 times the square root of 19, all over 5. And this would be my solution for number 1. And if I go to number 2, first thing I might want to do for number 2 is to simplify this a little bit. I have 4, 8, and a 4. If I divide everything by 4, I would just have x squared plus 2x plus 1 equals 0. And so then if I plug everything into the quadratic formula, I would have negative b, which is negative 2, plus or minus the square root of b squared is 4, minus 4 times a, which is 1, times c, which is 1, over 2 times a, or 2 times 1, which is 2. So in the square root sign, I'm going to have 4 minus 4, which is 0. And so the square root of 0 is just 0. And so it's going to be negative 2 plus or minus 0 over 2. And so this only has one solution, which is negative 1. Let's see how this works with a problem that looks like this. We have negative b is going to be negative 3 plus or minus the square root of b squared, which is 9, minus 4 times a, which is negative 2, times c, which is negative 5, over 2 times a, which is negative 4. So if I take the radical part, it's going to be 9, and I have 3 negatives now. So it's going to be minus 4 times 2 is 8, 8 times 5 is 40. And so this is negative 31. And so my answer is going to be negative 3 plus or minus the square root of negative 31 over negative 4. And I could simplify that to something like this. 3 plus or minus I radical 31 over 4. And so these negatives would cancel each other out. These negatives here, the plus would become the negative would become the positive. But my answer would look something like this. So let's just take a look at this. We did 3 problems, and this tells us something. This is called the discriminant, and that discriminant tells us if there are 2 real solutions. If it is a positive number, we know there are 2 real solutions. That was the case that we had in number 1. It was a positive number. It was the square root of 76, and we have 2 real solutions. It also can tell us if there are 2 imaginary solutions. If it's a negative number, that was the case here in number 3. The b squared minus 4ac was a negative 31, and if that's the case, we have 2 imaginary solutions. That's what we had in number 3. And then it also tells us if there's 1 real solution, and that would be the case if it was equal. That would be the case if it was equal to 0, and that was the case in number 2. The absolute value was equal to 0, and we had just 1 solution. And so the discriminant tells you how many solutions you have. And that's what's on the topic for today. Good luck on your homework, and we will see you tomorrow in class.